This is question number 51 of NSEP 2022, and the question is: two identical Carnot cycle engines operate between maximum and minimum. Temperatures are T1 and T2 and volume limits VA, VB, VC and VD as shown in figure. This is figure, and given that VC upon VA, this VC upon VA is equal to E cube, and T1 upon T2 is E, where E is the base of natural logarithm. Engine 1 operates on monatomic gas while the engine 2 on diatomic gas. So, options are: ratio of volumes VB1 upon VB2 is E. Ratio of work done per cycle for the 2 is W1 upon W2 is equal to 3. Ratio of work per cycle for the 2 is W1 upon W2 is equal to 1. Ratio of efficiency of two engines eta1 upon eta2 is equal to 1. And this question is also has more than one option. So we have to check all the options. So if we see this diagram, then BC and AD show the adiabatic. So for adiabatic, we know that T1 V1 to the power gamma minus 1 equal to T2 V2 to the power gamma minus 1. So for BC, we can write T1 temperature from B to C. VB, we can take VB gamma minus 1 equal to T2, at temperature of T2, C point is T2, VC to the power gamma minus 1. This is equation number 1. And for AD, we can write similarly T1 A means VA to the power gamma minus 1, T2 VD to the power gamma minus 1. This is equation number 2. So we can write from equation 1 and 2, T1 from equation 1, T1 upon T2 is equal to VC upon VB to the power gamma minus 1. And from equation 2nd, this T1 upon T2 is equal to VD upon VA to the power gamma minus 1. And we can write VC upon VB equal to VD upon VA, or VB upon VA, VB upon VA equal to VC upon VD. VB upon VA equal to VC upon VD. This is equation number 3. Now we know that work done during BC and DA together is 0. Is 0. This is BC and DA. So it should be together equal to 0. So total work done we know the formula W equal to for T1 temperature nRT1 log VB upon VA minus T. It should be T1. And next nRT2 log VC upon VD. This is total work done for T1 temperature and T2 temperature. So W is equal to nR T1 minus T2, as VB we have from equation number 3, VB upon VA is equal to VC upon VD. So this VB upon VA should be equal to VC upon VD. So it should be log VB upon VA. So W is equal to NR T1 minus T2 log VB upon VA, or we can write VC upon VB to the power gamma minus 1 is equal to T1 upon T2, and in question it is given that T1 upon T2 is equal to E, and VC upon VB is equal to e to the power 1 upon gamma minus 1. Now we can solve VC upon VB, VC upon VA. We can write VC upon VB upon VB upon VA, and VB upon VA, it should be equal to VC upon VA upon VC upon VB. VC upon VA upon VC upon VB. VC upon VA is equal to E cube. It is given in question. This is VC upon VA. So VB upon VA becomes VB upon VA is equal to, this is E cube, upon, this is VC upon VB, that is 1 upon, e to the power 1 upon gamma minus 1. So it becomes VB upon VA equal to E cube upon e to the power 1 upon gamma minus 1. If we solve it for monoatomic gas, for monoatomic gas, gamma becomes equal to 5 upon 3. So VB upon VA is equal to E cube upon e to the power 1 upon 5 upon 3 minus 1, or E cube upon e to the power 5 minus 3, 2, 2 upon 3, 3 upon 2, e to the power 3 upon 2, or it becomes e upon 3 upon e to the power 3 by 2, means e to the power 3 by 2. This is for monoatomic, we can write it VB1. VB1 upon VA is equal to e to the power 3 by 2. For diatomic gas, gamma is equal to 7 by 5. So we can write VB2 upon VA is equal to E cube upon e to the power 1 upon 7 by 5 minus 1. So it becomes E cube upon 7 minus 5, 2 upon E cube upon e to the power 5 upon 2, 7 minus 5, 2, 5 LCM, 5 upon 2, or it becomes e to the power 1 upon 2. So it if we take it is equation number 5, it is equation number 6, and it is equation number 7. So now, if we divide equation number 6 by 7, then it becomes VB1 upon VA upon VB2 upon VA is equal to e to the power 3 upon 2 upon e to the power 1 upon 2, and it becomes VA cancel out. This is E. So VB1 upon VB2 is equal to E. VB1 upon VB2 is equal to E. And if we check the answer, VB1 upon VB2 is equal to E. So option A will be the correct answer. Now we will check for another option, as this question having more than one option. So now we know that W is equal to NR T1 minus T2 log VB1 now becomes VB1 upon VA. So NR T1 minus T2 log VB1 upon VA. It becomes log VB1 upon VA should be equal to 3 by 2 from this equation number 6. And similarly we can determine if we take it W1, now we can take W2 is equal to NR again T1 minus T2 and now log VB2 upon VA and NR T1 minus T2, and it becomes 1 by 2 from this equation, e to the power half. If we take log, then it becomes half. So log VB2 upon VA, it should be half. Now divided by W1 by W2, NR T1 minus T2 are common. So 3 by 2 upon 1 by 2, it becomes 3. So now we should check the answer. And W1 upon W2, one option is 3 and one is 1, and in our solution this should be the correct answer and this is wrong answer. So A and B both are correct, C is wrong. Now we will check for option number D, fourth option. So we have to determine the efficiency, and we know that efficiency depends upon the temperature. It should be T1 minus T2 upon T1, and we know that, so as the efficiency depends upon the temperature, so in both process eta 1 becomes eta 2. Efficiency in both options will be the same. So eta 1 upon eta 2 is equal to 1, and in fourth option we know that eta 1 upon eta 2 ratio of efficiency, eta of two energies, eta 1 upon eta 2 is equal to 1. So this answer also will be the correct option. A, B and D, these three options are correct in this question. Only one option, C, will be the wrong answer. A, B and D are correct option. So dear students, thank you very much for your patience, and we will meet again with the solution of next problem.